we've started working with common denominators, let's get into the heart of today, okay? So we're going to add and subtract rational expressions with unlike denominators. Your first step is to find the LCM, okay, or the common denominator. Then you're going to multiply the numerator and denominator by whatever factors that they need to get there. You're going to expand the numerators or multiply them, but don't do anything to the denominators, and then add. So here's an example of it, and you can walk yourself through it if you wanted to. This is our original, okay? This is it expanded, so we got common denominator. Then they distributed or multiplied the numerators, but you keep the denominators, okay? And then you ended up with your final answer. So let's look at this one. So the first thing you have to do is find a common denominator. Okay, so I always just write it down here like this so that I know I'm going to have to change both of them, right? Well, I need an x plus 1, right? Because that's one of our denominators. And then I also need a 2x plus 1 because that's the other denominator. It's kind of like this being a 2 and a 3. You would just multiply 2 times 3. So from here, now I just need to think, okay, in this first fraction, what am I missing? Well, I'm missing the 2x plus 1. So this becomes 2x plus 1 and 3x plus 1. In the second one, again, what are we missing? We're missing the x plus 1. So this one becomes 2x minus 1 times x plus 1. So what we have to do here is now FOIL and then rewrite it as one fraction. So if we FOIL on the left, we get 6x squared, then it would be plus 2 plus 3, so that would be plus 5x, and then plus 1. In the purple, when we FOIL, we'd get 2x squared plus 2x minus x, which would be just plus x, minus 1. Now, I put these in parentheses because, again, remember, if this were a minus, we would have to distribute it. But because it's a plus, we can just combine like terms now. So now we would have 8x squared plus 6x, and that's it. And our denominator would stay the same. And now we factor if we can. This actually is factorable in the numerator. We can take out a 2 and an x, and you're left with 4x plus 3. Now, although it was factorable, it doesn't let me cancel anything, so we leave it just like this. Again, I can't cancel 2x and 2x because that's actually not 2x in the denominator, it's 2x plus 1. Looking at the next one. Before we start, we have to factor it. So I'm going to factor this denominator first. If we t-chart it, first times last is negative 16. That would be negative 8 and 2 to add to negative 6. So my denominator is x minus 8 and x plus 2. The 8 stays the same as well in the numerator. The second one, first times last, is negative 40. What multiplies to negative 40 adds to negative 3. That would be negative 8 and 5. So now I need to come up with my common denominator. So we take all of the first one, which is x minus 8 and x plus 2. And then we take all of the second one, but we don't repeat anything that we have. So in the second one, we already have an x minus 8, so I don't need to write it again, but I do need the x plus 5. So now again, in the blue, I'm focusing on what I have and what I need. Well, it has the x minus 8 and the x plus 2. It just needs the x plus 5. So my numerator would be 8x plus 40. In the second one, it has the x minus 8 and the x plus 5. It's missing the x plus 2. So I multiply the top by x plus 2. And that becomes 9x plus 18. Now, Think about them in parentheses, and if this were a negative, we need to distribute it, but it is a positive, so we can just add straight across. That becomes 17x plus 58, and then over x minus 8, x plus 2, x plus 5. It does not matter what order you put those in. And that ends up being my final answer.